Okay, so we might have heard of light as a wave or as a particle. And today we're going to look at what happens because light acts like a wave. Or, in other words, if we look at it the other way around, why do we classify light as a wave? Looking at light as a wave, and we'll explore how two key points lead to a phenomenon we call refraction, or how these two key points lead to light refracting. So that's what we're moving towards, refraction. But we're going to first start off with a question about a beach. So if this yellow line at the bottom here represents the beach shore, and this represents a wave crest, so these are waves coming into the beach. This other yellow line represents a wave crest far out to sea. The question we could ask is, why do waves that start out at a large angle to the beach finally reach the beach in parallel? That is, why do they finally reach the beach in line with the beach? And we can see the wave from here to here to here is becoming more and more parallel with the beach, to the point here where it's pretty much parallel to the beach, and then here where it is exactly parallel to the beach. This is because waves will speed up or slow down depending on what medium, i.e. stuff, they're travelling through. So this is the key point. Waves travel at different speeds through different media, through different amounts of stuff. There's our key point one. This is leading us to our point of refraction. Waves will speed up or slow down depending on what medium, what stuff, they're travelling through. For the waves, shallow water represents a slower medium. So the wave in the deeper medium has more time to catch up. Now this might not seem so clear right away, so we're going to look at an example to get our heads around this a bit better. Here's another example where we've got a fast and a slow medium. We can imagine this as pavement, and this is a slow medium. So waves find deeper water to be a faster medium, and shallower water to be a slower medium. Whereas people running, or animals running, will find pavement to be a faster medium, and sand to be a slower medium. By medium, we just mean anything that can influence the speed. So imagine, there's our key point. Waves will speed up or slow down depending on what medium or stuff they're travelling through. So imagine we've got a race. We've got a start over here on the pavement, and we've got a finish over here on the sand. But this race isn't perpendicular, isn't this way, isn't perpendicular to the boundary of the media. It's actually at an angle. And we've got two races. We've got Simba and we've got Pumbaa. So they're both going to race from the start here to the finish. And there's one key assumption we've got to accept here, and that assumption is that Simba and Pumbaa can run at exactly the same speed. Whether they're running on sand, if they're both running on sand, they run at the same speed, and if they're both running on pavement, they also run at the same speed. So the race starts. Ready, set, go. Both run for 5 seconds, all on the pavement. So who's going to be further ahead? Who's going to be closer to the finish line? Well, we've already established that they both run at the same speed. So we know that they should have run the same distance after 5 seconds. Yep, that's what's happened. But then they both run for another 5 seconds. This time Simba's on the sand. We can see he's already reached the sand. And Pumbaa, P, is on the pavement. What's going to happen? Who's going to be closer to the finish line? Well, now Simba's run on the slower medium. So he's going to not have travelled as far. And how far is Pumbaa going to have travelled? Well, he will have travelled exactly the same distance as he did the first time, because he's still running the same speed. So he will have travelled this arrow's distance again. Let's see what happens. Yep, he travelled exactly the same distance, whereas Simba travelled a shorter distance. Finally, both run another 5 seconds. This time they're both on the sand. How far are they going to go this time? Well, Pumbaa's already further ahead. But because they run the same speed, Pumbaa's going to run as far on the sand in 5 seconds as Simba can in 5 seconds. So Simba's going to run another 5 seconds and get about here. Pumbaa's going to run another 5 seconds and get about here. Let's just check that. Yep, so that's what happened. Now, this is two people racing, but we can see that what I was actually trying to represent was this is 2 points on a wave crest. So this is the wave crest. This is the Pumbaa further out to sea and Simba closer in. Pumbaa's they're both in a fast medium. After 5 seconds, they've both been travelling in the same medium, so we still see the wave crest is at the same angle. However, after Simba has reached the slower medium and Pumbaa has reached the faster medium, we see the wave crest change angle. Then they both travel in the same medium again, both in the slow medium, and the wave crest stays at the same angle. This is exactly the same example as what we saw on the beach. We'll see that the waves refract, this key word, as they pass through different media. But there is one difference between this example and this one, and that is that here, the refraction is instant, because we travel from one media instantly into another, from a fast instantly into a slow, whereas in this example, we're traveling gradually into a slower medium, because the water is gradually getting shallower. So we're going to see this more of a bend rather than this sharp change. So we call it bend of light as it passes through different substances refraction. And this came from our key points. First off, waves will speed up or slow down depending on what medium or stuff they're travelling through. And secondly, this means that when a wave, such as light, hits a different medium, it will be bent. So these 2 points, waves speed up or slow down, and it will be bent, leads to this word, refraction. So we call bending of light as it passes through different substances refraction, or even bending of waves, bending of any waves as it passes through different media or different substances refraction. So we've seen pictures of Pumbaa and Simba racing, we've seen pictures of waves, now we'll see a picture of light exhibiting this refraction. Here it is. So here we've got a light source that's giving out a nice refined beam of light. Initially it's travelling through what light finds to be quite a fast medium, which is air. But then it comes across this slower medium. This is glass or some sort of plastic. Now light finds it harder to travel through glass than air, so glass to light is a slower medium. Therefore we see this bending. Again, our key points, wave will speed up or slow down depending on what medium they're travelling through. And this means that when a wave such as light hits a different medium, it will be bent. So again, we can imagine Simba being on this side and Pumbaa on that. It's exactly the same example. This is how the wave nature of light enables refraction.